Let's talk about electrons and quantization of electric charge. Now, way long ago when people were first discovering electrification, they had no idea what was causing it. But later experiments at the end of the 19th century showed that electric charge in ordinary materials is accomplished by the transfer of electrons. So there's a certain type of particle that will be transferred from one object to another when we have charging going on. All right, so electrons have a negative charge. And that means that when I rub silk on glass, the glass gets a positive charge. Well, how does it do that? Now, people might think the silk gives up protons to the glass, but that's not what happens. Protons stay where they are. Wherever the protons are, that's where the silk is. All right, so the silk isn't giving itself up to the glass. So instead of that, what happens is the silk strips electrons away from the glass. So that means that the glass has less electrons. It's still got the same number of protons. So that means that now it has a positive charge. And that's something that sometimes is confusing to people, especially since you know that there's all these proton business, right? And they've got positive charge. So you think, well, geez, if you got positive charge, you got too many protons. But that's not the way that it works. It means you have too few electrons. Now, along the same lines, if you rub fur on amber, the amber is going to get a negative charge. And that means the fur is giving its electrons up to the amber. So now, whenever you have a negative charge, it means you've got too many electrons. Whenever you've got a positive charge, it means you've got too few electrons. And that's a very important thing for you to understand how that works. It's not the protons that are moving. It's always the electrons. Whether it's a positive charge or a negative charge, it's always the electrons that are moving. All right. Now, the electron charge is negative 1.6 times 10 to the minus 19 coulombs. And since all these charge transfers are associated with transfers of electrons, it means that all charges that you can get on an object must be a multiple of this number right here. So 2 times 10 to the minus 19 coulombs is not possible. You cannot have that charge on anything. It doesn't matter. Even if the material is not ordinary, you cannot have 2 times 10 to the minus 19 coulombs. What about 3.2 times 10 to the minus 19 coulombs? Well, that's just 2 times this with a negative sign. So that means that 3.2 times 10 to the minus 19 coulombs is associated with an object that is missing 2 electrons. All right, what about negative 8 times 10 to the minus 19 coulombs? Well, 8 is 5 times 1.6. So that means that if I've got negative 8 times 10 to the minus 19 coulombs, I've got 5 electrons too many. So that's the idea. Should always remember 1.6 times 10 to the minus 19, and everybody got to be a multiple of that. If it's not a multiple of that, not possible. And that's electrons and quantization.